2.4. 2.4 is going to be about complex numbers. They're really pretty easy. So let me show you. So you guys know about the square root of like 9, right? All right, so what's the square root of 9?
3.
Yeah. And why is the square root of 9 3? Like if a younger child, 10-year-old, asks you why square root of 9, what would you say? Don't bother me, kid, just do what I say. No. You would say 3 times 3 is 9. Right. That's the square root idea. Totally. So then what would the square root of negative 9 be? I think we might have briefly talked about this. So remember, same question. What times itself is negative 9? Because that was the question we all agreed we explained to the 10-year-old. So what times itself is negative 9? Nothing. Do you see that? Right? Because 3 times 3 is certainly not negative 9. Negative 3 times negative 3 would be positive. You think we just need one negative, one positive. Well, that's not the same number times itself. That's times its opposite. That's not what square roots do.
I thought you said no square roots are negative.
Yeah, you can't, right. You can't put a negative in the root. Exactly what we're observing.
That's like a rule.
Yeah. And can you see why? But I want you to see why that's a rule. Does that make sense? Do you see why there can't be a normal answer to the square root? Because there's no number times itself that's negative 9, right? We all agree that's what square roots are about. What times itself is this thing? And you can't do, nothing times itself is negative, right? Negative times itself goes back to positive. You'd have to have one negative, one positive, and that's not times itself. That's times its opposite. Well, then what do? There's no real answer to this thing.
Oh, so it's all set.
So what do we do since there's no real answer to this thing? We use our imagination. And I'm not kidding. So, because there's no real answer, right? When there's a negative in a root, you just say, well, if that negative wasn't there, what would the answer be? What would the square root of 9 be? 3. And then you just go, yeah, but the negative was there. Okay, I'll just say then it's 3 imaginary units. And that's really the answer.
Really?
It's 3i. And the I does stand for imaginary units. Feels like I'm just making, but I'm telling you the truth. This is the truth. It is 3i, it is 3 imaginary units. So it's actually very easy. It's weird, but it won't be hard. This will be a very easy section. So let's make sure you're making sense. What's the square root of 4? 2, right? So what about if we stick a negative in there? What's it going to be? 2i. It's as easy as that. Yeah, you just grab the negative, pop it out. I just do it like normal. Okay, what's the square root of negative 25, for example? 5i, exactly. Because you just grab the negative, throw out the I, square root of 25 is 5. So it's not hard. It's a little weird, but it's not hard. Just a negative in there, pops out an I. And then just do the root like normal. If I was you, I'd be thinking, this is imaginary? You kidding me? Heron, it's imaginary? Why are we doing this? I thought this stuff was for like engineering and stuff. It actually totally is. You have your phones. Feel free to type into Google real life applications of imaginary numbers or complex numbers, same thing. And there's tons of them. I actually did a little bit while I was engineering before I changed the math. Anyway, it's really useful anytime you have two sides things, but enough said. Let's get on with it. So they do use them for things. All right. So with that said, let's do the actual. That's all you got to do with negatives in a root. Just pop out an I. So here we go. So we have minus, here's the question, minus 5 square root of minus 121. Okay, so I would use my calculator. I don't go around just expect you to go around just know. Well, first thing, what is that negative going to do? Inside of a root, pop out an I, and it's gone. So it doesn't come out negative. It's not going to hit that other negative and make positive or anything like that. No. Right, I want to be clear with you. Negatives in a root pop out an I, not a negative. Because they're imaginary. They're not real. Right? So it pops out an I. That's what they're testing that you know. So it's going to be minus 5i. And then you just do the square root of 121, your calculator. Just hit the button. It's 11. So it's minus 5i times 11, which is 5 times 11? Minus 55i. That's our answer. Minus 50. Did you see what we did then? One more time. When you have a negative inside of a root, just pop out an I. And then just do the root. There's no more negative now. The root of 121, your calculator tells you is 11. 5 times 11, 55. It's as simple as that. It's a little weird, but it really isn't too tough. I'm going to try the next one here. It's a minus 9 plus root
Oh, I forgot to put the
negative 64. Try that one. You got a negative in the root. On part number 2 here, pop out the I. All right. So, negative 9 plus. Okay. So what does that negative do? Just pops out an I, and then you just do the square root of 64 like normal. And what's square root of 64? 8. So it's just negative 9 plus 8I. Is that making sense? So a negative in a root just pops out an I, and then you just do the square root on your calculator. Square root of 64 is 8. Now the I that popped out. Does that make sense? So the negative inside of this root, it pops out an I right next to the root. It doesn't go over here or anywhere else. When it pops out that I goes immediately in front of the root. Doesn't travel anywhere else. So that little negative pops right in front of the root, right there, and then square root of 64 is just 8. We're done. You can write this I8 or 8I. It doesn't matter. It's good either way. How about number 3? Square root of negative 4. Yeah, this is a better section, isn't it? This pops out an I. And then the square root of 4 is 2. You could write it I times 2. We just normally put the number in front. It's just traditional. But either way is fine.
I was gonna ask you that because I kind of got confused in the first one. I mean, kind of like that one, because you got the 5, and that you would have to multiply 5I times,
Oh, yeah, you're wondering why these two multiply? Yeah, good question. Let me answer that. That's a good question. And the idea behind that is, what if you had 3 things multiplying? You could do the first 2 and get 6 times 4, and that'd be 24. But it would also be okay to multiply the front and the back first. 2 times 4, what would that be? 8 times 3, same answer. So my point is, when 3 things are multiplying, you can multiply any 2 first. First 2, front and back 2, doesn't matter. So that's all I really did back on that problem, right? Right here, I just did the front and the back. So that's okay, not just for I's, but in all situations. That's the same thing. That's always valid to do. Am I answering your question? Does that make sense?
no, actually, what I got, I mean,
He's talking about what?
Let's move on with number 4. So on number 4, negative 12 plus the square root of negative 9. So that little negative is gonna, can you see that one okay? Maybe I better, well, can you see that one okay? I can. All right. So here it is. I wrote it a little bigger. So remember what we do? We take that little negative inside the root and we pop an I right to the front of that root. So we get negative 12 plus I times 3 or 3 times I, same thing either way, plus 4 minus, and that little negative in the root, again, pops out an I, and then the square root of 36 is 6. And you can write 6I, I6, whatever. And now we just combine like terms. Probably what you were thinking. It's exactly right. Am I going too fast? Is that good? So minus 12 plus, if you lose $12 and you gain back 4, where's your bank account? Down 8, right? If you lose 12 and gain back 4, you're down $8. And then this and this combine. So it's a gain of 3 I's and then a loss of 6 I's. So you've lost 3 I's.
That wouldn't be good.
That's right. Don't even have 3 I's. And there we go. That's it. Here's number 5. This won't be too bad. Minus 2I times 9 plus 8I. Okay, so we're going to start doing work with the I now. The imaginary, it's called the imaginary unit. That is what it is. And so we're going to distribute. It's like normal. All the same normal rules are in effect. But there's one special rule, which I'll show you. So anyway, first off, minus 2i times 9, what's that going to be? Minus 18i. And then minus 2i times plus 8i? Minus 2 times 8, 16. I times I? I squared, huh? Just like x times x is x squared. But we do something special with the I squared. But so far so good? This is where I need to tell you the one new, and probably the last,
I see
special
what-
rule.
I see what the problem is.
So far so good. So I just did two, just like an x, I just did exactly what you would do with an x, right? 2i times 9, 18i, 2i times 8i, 2 times 16, I squared. Totally normal. Now, here's the extra trick. You never leave I squared. We leave I will just stay I, not do anything else with that. But I squared, we never leave. I squared. Now, what is I squared?
That's impossible on top
Well, I squared.
of it.
Let's think about it. Hey, let's talk about square roots. What's the square root of 9 again?
3.
3. So what's the square root of 9 times the square root of 9? Well, it's 3 times 3, right? Because we just agreed square root of 9 is 3.
Yeah.
So it's 3 times 3, and what's 3 times 3? 9. So the square root of 9 times the square root of 9 is 9.
It's a straight up.
Right. Yeah, and we know the rule, right? Two nines inside the root, 1 9 outside. No big surprise. So what's another way, let me get rid of this. What's another way we can write square root of 9 twice? Can't you write square root of 9 squared? Isn't that the same thing? Right? 2 of them, squared, same thing. And it's just 9. Right? You know that rule, right?
Something's imaginary.
So what's the square? We'll get there, but let's start with the real. Square root of, 17 squared. What's it going to be? 17, right, exactly. Because everybody see the pattern? The 2 and the root are just opposites, aren't they?
Yeah.
They just cancel. Because really this would mean root 17, and 2 17s in, 1 17 out. You know that rule quite well. That's exactly correct. Well, let's just do that exact same rule when it comes to I squared. So what rule? One more time. Root 17. Math, you know what math is? It's the science of patterns. It's watching, following, predicting, describing better and better and better patterns. That's really what math is training you to do. Get better and better and better and better at watching, predicting, following, understanding patterns. And that's all science is. How do they figure out everything? They looked in the human body and saw the pattern. Physicists looked and saw the patterns with gravity and speed and right. That's logic. That's how we separate from the beasts, right? We think and follow patterns. So what's the pattern again? Chalk with the pattern again. What does that equal? 17. So when you have something in here with a root and a square, they cancel and you just pop that thing out. Okay. So what's I squared? Well, what's I? Oh yeah, I haven't showed you. I'm not being very helpful. I forgot to tell you what I is. Let's back up. What's the square root of negative 4? First, what's that again? 2i, because you just pop out the negative and right. So what's the square root of negative 1? Pop out the negative. It's an I. Square root of 1? Yeah, it's just I times the square root of 1. And what's the square root of 1? It's just 1. So that's just I. So now we know what I itself is. What's I itself? Square root of negative 1. So what's the square root of negative 1 squared? Follow this rule. When you have something with a root and a square on it, they cancel and out pops the thing. So these cancel and out pops the negative 1. So the square root of negative 1 squared must be negative 1 by following the same pattern we've been doing. And what is the square root of negative 1 again? So what is I squared? All that logic to show that I squared must be negative 1. Which is weird. Stop and absorb that for a second. What's I? Well, it's some weird square root of negative thing that's imaginary and not real. But what's I squared? Real life, plain negative 1. No imagination needed. I squared pops back into the real world.
Oh, no.
You track with that?
Yeah.
Right? I squared is a real number. Even though I itself is imaginary, I squared pops back into the real number world. All right. So anyway, long story short, you don't have to follow all the intricacies of all that. But all you'll need to know, it won't be hard. All you really need to remember is any time I squared shows up on the scene, you replace it with -1. You don't replace I. We leave I because I is weird. I is just something weird. We just leave I as I. But we never leave I squared because I squared is just plain -1.
And then that would be kind of -1.
So you just pop in a -1 there. So you got -18I minus 16 times -1, which is plus 16, and we're done. So yeah, so that's all you really, if you didn't understand all that little other stuff, don't worry about it. Just remember, anytime you see I squared, put in a -1. We never leave I squareds. We never leave them. We just pop in a -1. They are just -1.
So when that happens, that means the exponent right next to it could be flipped.
I don't know. Maybe we can talk about that later. But let's try this next one. So let's try 3 minus 6I times 4 minus 10I. So just FOIL that out. You know about foiling, right? Like the first one goes to both, and the second. Just do what you would normally do with an X. But when I squared shows up, make it -1. Everything else is the same. There's nothing else new. All right, I'm going to jump in with you. So this 6 goes to both. 3 times 4 is 12 minus 30I. He's done. Is that okay so far? I just took that 3 to both. And now this -6I, that's his negative sign, will go to both. -24I and -6I times -10I plus, two negatives make positive, 60I squared. Good so far? That's just normal, first to both, second to both, just like you would with an X. Nothing special. And now 12, that's just 12. These two in the middle are like terms, aren't they? So they can combine. What is that? Minus 54I. And now, what do we do with I squared?
Times the
Pop in a -1. Yeah. So notice, we leave the plain I as plain I. We don't mess with that. But I squareds, we never leave them. We just pop in a -1. So pop in a -1. And what is 60 times -1? Yeah. So if you want to save a step, it's always just going to change the sign of whatever it's with. That's it. Yeah, so if you got a plus 60 with an I squared, you know it's going to be minus 60. If you got a minus 60 with an I squared, you know it's going to be plus 60. Because it's just a -1. It's just going to change the sign. That's right. That's all it does. So this will be minus 60. So now these two can combine, actually.
Yeah, now I can.
They're just both plain old numbers. 12 minus 60, what is that? Minus 48. Thank you. Minus 54I, and we're done. So again, I we leave. Plain I, regular I, just stays I. But I squared, we replace with -1.
Are we going to have a -I cubed and...
No, we're not going to go there. I don't think. There might be one problem. I'm not going to go there on the test for sure.
Oh, okay.
Yeah, they do that in pre-calc more. I don't think we do it at all. I think I cut those out.
So there is such a thing.
Oh, there is, yeah. And it's cycles. There's an interesting cycle for, it's something they study in pre-calc.
Oh.
But we're not in pre-calc. So, -1 plus 3I, quantity squared. What do you do when you have a 2 power on something? Write 2 of them, exactly. So it's going to be just like the last problem. So write 2 parentheses. Oops. And do the same thing you did last time. Take it from there. So take that -1 to both. Watch your signs. Be careful there. +1, right? Minus 3I. And then the plus 3I goes to both. Minus 3I and what? Plus 9I squared. Is that good so far? And then these two in the middle, those are like terms, minus 6I. And then what are we going to do with that plus 9I squared? Flip the sign, because I squared's -1, so that'll just become a -9, or subtract 9, same thing, huh? So 1 subtract 9, minus 8, minus 6I. There's that word conjugate again. So now we do have to know the meaning of that word conjugate. Didn't we talk about that briefly? Maybe not. Maybe I'm thinking of some other class. Honestly, I teach a lot of different algebras. Sometimes I forget what I've said where and what we've covered where. Conjugate, well, let me just give it to you then. it means opposite sign in the middle. So this has a plus in the middle, so we'll change that to minus. If it had a minus in the middle, we would change it to plus. So it means 2 minus 11i in this case.
Oh, yes, conjugate.
So conjugate means the opposite sign in the middle. I don't know why that word means. I know nothing about that word other than that's what it means. But they did say product. What does product mean? Multiply. Yeah, they want us to take the first one, the 2 plus 11i, and multiply it times the conjugate, the opposite sign in the middle, the 2 minus 11i. So they just want us to do another one of these, first to both, second to both things, but with the conjugate. What's going to happen is the 2 middle terms will cancel. That's what always happens when you use the opposite sign. You'll see. We'll get one positive 22i and one negative 22i, so they'll drop out of the middle. So the 2 is going to go to both. 4 minus 22i. And the 11i is going to go to both. Plus 22i. And then 11 times 11? 121. I squared. 12 times 12 is 144.
Yeah,
We good to there? So I just did first to both, second to both like usual. And you see what's happening in the middle there? Yeah, that's because we used 1 plus 1 minus. That's why we're into using the conjugate. And I'm about to show you a problem where we will use it. Because it makes that happen. And we like that. We like the eyes to go away because they're imaginary. They're not real. We'd like them to drop out. Yeah, but what about that other one? Actually, you know what's going to happen with that other one, huh? What's going to happen with him?
He switches the sign.
He's a negative 1, so he switches the sign, becomes a plus 121, huh? So the answer is just a plain old number, 125. No more eyes at all. You see that? Turned it into a normal number. By using the what? The conjugate. Because it drops out the I. Well, that's why that's so important. So 10, 11, 12 are all the same as what we've been doing. But then 13 is the one other new concept. So I'll do 1 or 2 of these with you, and hopefully that'll be good. Let's see. So this one, now we're dividing the 2 complex numbers. So this is the hardest thing in this section. So when you have I and plus or minus in the denom, when you have an I and a plus or a minus in the denominator, multiply top and bottom by the conjugate. This is where we want to use the conjugate. By the conjugate, which means opposite sign in the middle. So that's the game plan. So when they give you something like this, that has an I and a plus or minus in the denominator, then you use the conjugate of the denominator. Basically, we want to get rid of the I from the bottom. So how we do it is we multiply by exactly that denominator, top and bottom, but opposite sign in the middle. Does that make sense? That's the conjugate. So if they'd started with a minus, I would have done plus over plus.
Right.
So whatever sign they start with, I use the exact denominator, but opposite sign in the middle, the conjugate. Why? Because that, as we just saw, will make the I go away on the bottom. It'll be beautiful. Let's see it. So this 5 is going to go to both. So on the top, we do first to both, second to both, and the bottom. It's a lot of work. It's going to be our last problem. 5 times 3, 15 minus 5i. He's done. So I let that 5 go to both. 5 times 3 and 5 times I. 15 minus 5i. And now, this minus 5i is going to go boom, boom. Minus 15i. And minus 5i times minus I plus 5i squared. You know in a minute, that's going to become a negative 5, because that's what we do with I squared, right? On the bottom, this 3 is going to go to both. 9 minus 3i, he's done. First to both, second to both. And this plus I is going to go to both. Plus 3i minus I squared. See what's happening in the bottom there? Bye-bye, i's. See how when you use the conjugate, the opposite sign in the middle, the i's drop out, and the I squared, that's going to drop out too and be negative 1. Right? Negative 1 is going to go right there and right there. So it'll become plus 1, won't it? So what do we got here? 15. Minus 5i minus 15i? Like terms there? Minus 20i? And then what about plus 5i squared? Minus 5, because that I squared becomes negative 1 and switches the sign of whomever he's next to. Yeah. This isn't too bad. On the bottom, these cancel. And it's just going to become 9. So minus I squared is minus a negative 1, which is really plus 1, which is 10. Right. The bottom becomes 10. What's the top? 15 minus 5? 10 minus 20i. And they're both over 10.
Is it simplified to 1?
Yeah, good question. So what can we do? We all good to there so far? Notice all the i's are gone from the bottom, huh?
Right.
No more i's in the bottom.
No, you cannot.
Can I cancel out these 10s?
No, because the subtraction of.
Costco says no. But hold on.
Oh, so it's imaginary.
No, same rules,
Oh, okay.
even in imaginary Costco.
Okay.
But what does Costco say? Does that mean that they won't sell you anything? You come in there and go, get out of here. You ain't gonna sell nothing here. We're package deals. No, as long as you buy the whole package, they're good. In other words, if you do them both, you're okay. Can we? Can we do them both? Yeah, do it. 10 into 10, 1 time. 10 into 20, 2 times. 10's gone from the bottom now. 1 minus 2i. No, that's right.
Oh, yeah. No, I got the answer.
Yeah. That is the answer. Yeah, so if you can divide both of them, the whole package, you do it. Remember, that's what the packaging is about. You buy both or nothing. You just can't do only one. Like, for example, let me show you what I mean. What if instead of a 20 here, this had been something like a 7? Well, then we would just stop right there. We wouldn't take another step because the 10 has to go both or nothing, right? Because it's a package. It's both or nothing. But as long as it can do both, we do it.
If you would have a 2 there, 2i.
So this is 20, so it goes in there 2 times. What's that?
If you would have a 2 there, 2i.
It could-
Do a
it-
factor? Do a factor?
What's your question, Sabina?
If you would have like a 2i, minus 2i.
Like what if it's 25?
So do you mean, Sabino, like what if this was a 2i to begin with? Good question. Yeah, how about Sabino's question? It's a good one. What if it had been like this? What you do is you still, as long as all 3, meaning this guy, and this guy, if they're all divisible by the same number, you do it.
Which will be 2.
Which will be 2. So yes, so I couldn't do the whole 10, but I could divide them all by 2. So I go divide by 2, leaves a 5. Divide by 2, leaves a 1. Divide by 2, leaves a 5. It would be 5 minus 1i, or just I, over 5. That would be the answer.
Oh, so
Does that make sense? Yeah. So as long as all 3 can be divided by the same thing, you do it. It's all 3 or nothing.